One key aspect of programming in Elixir is understanding control flow structures. They're vital tools that dictate how your program runs under different conditions. In Elixir, these structures are not just about directing traffic, but embracing the language's functional nature and pattern matching strengths. Let's dive in and explore how Elixir's if, else, unless, case, conditional, and guard clauses empower you to write clean, maintainable, and expressive code. Let's open up our Elixir shell with command space terminal and just go ahead and do IEX enter. Let's first check out if-else statements. We've used these already in the past and they're pretty easy to understand. They're pretty straightforward. If we do if 2 plus 2 equals 4, then it will do something. So it will say correct. And then else, if it doesn't equal 4, it will do the else statement. So incorrect. And then we can just do an end here. So when I hit enter, correct is going to display because 2 plus 2 equals 4. So that's correct. We can also write an if else statement, the shorthand version. So we can do something like this. We can do if 2 plus 2 equals 4, and then we can do a comma, do colon, and the true statement after, so correct. And then we can do a comma, else, colon, incorrect. And then we don't need the end or anything, and this is the shorthand version, and this will display correct as well. And if this wasn't correct, we would get the else statement. So if I change the 4 to a 5, then we get the else statement. Now, we also have the unless statement, which can be kind of confusing, but basically if the condition is false, it's true, if that makes any sense. I can't really think of a time I've personally used these, but they're worth knowing about. And the way this works is if you do unless instead of if, and then you do 2 plus 2 equals 5. So this is going to be a false statement. It will display correct and not our else block of incorrect. So 2 plus 2 doesn't equal 5. If the condition is false, it is going to go into the true block of the statement. So I personally think they're confusing. It's like a weird way of thinking. I don't use them, but they're worth knowing about. Now, a case statement in Elixir is used for pattern matching against multiple values. It allows you to compare a value against different patterns and execute code based on the first matching pattern it finds. So each pattern can have a corresponding block of code, making it useful for complex branching logic where multiple conditions need to be checked. Let's say we just have a variable called number, and that is equal to 10. Now, in our case statement, we're going to check against this variable, and then inside of a do block, you can have each case. So if that number pattern matches to 5, we would return it is 5. And then we can have, if it pattern matches to 10, which is the correct one, it is 10. And then you always usually have like a fall through clause. So if nothing pattern matches, you can just say it is neither 5 or 10. And then we'll close off this block. And since our number is 10, it's going to return it is 10 to us. We are just pattern matching down. And this is obviously a very simple example, but you could pattern match towards, specific items inside of a map for keys and values and all that sort of stuff. It's super powerful. Now, a conditional statement is used for evaluating multiple conditions sequentially. So it works like a series of if-else statements, allowing you to define multiple clauses, each with its own condition. Now, conditional checks each condition in order and executes the block of code associated with the first condition that's evaluated to true. Now, it's particularly useful when you have several different conditions to check and want to execute different code depending which condition is met first. A common practice is to include the final condition as true to serve as like a catch-all, or like in our case here, it's like the fall through default case. And now an example of a conditional statement is we can do something like this. We can set a variable, so age equals 20, and then our condition, instead of like case where we have a variable in the case block, right? Or an argument, I should say, we just do condition do, and then inside this block, we have all of our conditions. So if age is less than 18, we will return underage. And then our next statement could be if age is greater than or equal to 18. And now we can also do an and clause, and age is less than 65. So if it falls between 18 and 65, then we will do this case and we will return they're an adult. And then we can have our default case. So not an underscore this time like in a case. We want it just to say true because it's looking for a Boolean value. So if a condition is true, it's going to evaluate the code that is part of that condition. So if none of the conditions above this, then the final condition is automatically true. And we can just return then they're a senior because they're above 65. And then let's close off this condition. And when we get this back, we're going to get adult returned to us. And there you go. And that is a conditional statement. Now, guards are additional checks used in pattern matching, allowing for more specific conditions. They are used in function definitions, case statements, and other pattern matching contexts to ensure that certain criteria are met before the code is executed. So an example of a guard, we're just going to create a def module in here, and it's going to be called greeter. And then inside of this def module, we're going to have a function called greet, and we're going to pass in an age. And now a guard is, so part of our function line, we're going to just say when, and we can say is underscore integer, pass in age. So this function will only be used as long as age is an integer value. And then we can also say, and age is greater than or equal to 18. And then we're going to do whatever is inside this function. And we can just return a message, welcome adult. And then finish off that function with an end. And then we can also make a second function here. So let's say we'll call it greet as well. And it also takes an age, but this function will be called if age doesn't meet the criteria of being equal to or greater than 18. So we'll still check with a guard that it is an integer, but then without having the extra check of age greater than or equal to 18, we can say, sorry, you must be at least 18. Okay. And then we can end that. And then let's go ahead and just end our module. And when I hit enter here, we now have access to our module like we wrote our own, .ex file. So we can actually say, we can call greeter.greet. And now if we pass in a value of say 21, we'll get our welcome adult message. And then if we pass in a value of 17, we get our sorry, you must be 18. So that's how guards work. They're just an extra.
Hi, I'm Jacob. I help companies build scalable, fault-tolerant systems in Elixir. With over a decade of experience, I specialize in solving complex technical challenges, whether that's architecting new systems, implementing real-time processing, or scaling existing applications. I work with teams worldwide to deliver high-performance solutions that deliver results. If you need help with your next Elixir project, visit elixirmentor.com to schedule a call.
Condition that you can add on in the function clause, which is pretty cool. And we'll jump into better examples with these in a second. Now one thing, if we pass in a string here, we're just going to get an error because there is going to be no function that takes a string. So the following arguments were given to greet, and there's no function clause matching anything that takes a string. So our little is integer check is working, and so therefore we won't do any of the do block because there's no function clause that matches. So that is pretty cool. Now let's go ahead and close out of the IEX shell with Control CC, and let's CD into our desktop and create a new project. We're going to build a temperature converter that can convert Celsius to Fahrenheit or Fahrenheit to Celsius. And this is just going to be a quick example that can touch on a lot of these conditional statements in a super beneficial way. So let's create a new project, and we're going to say mix new, and we'll just call it temp underscore converter, hit enter. And then let's go ahead and just CD into that directory right away. And let's get our shell up and running with IEX space dash capital S space mix. And now we can just open up Visual Studio and we'll write code in a more readable way. Because I know the IEX shell can be a little hard, but for really quick examples, and let's close this project. That is our project from the last video. And let's open a new folder. And it's our temp converter project. We can close the welcome menu and expand the lib directory, and let's open up tempconverter.ex and just delete our hello world function. And now we are ready to write some code. We want to write a function that will convert Celsius to Fahrenheit and then also convert Fahrenheit to Celsius. We're probably going to need a couple functions. And one of those functions is going to have to be able to convert Celsius to Fahrenheit. And then we're going to need a function that does Fahrenheit to Celsius. And then we're going to need a function that we're calling where we either tell it to convert a certain number from either Fahrenheit to Celsius or Celsius to Fahrenheit. So let's just write our first little shell to our function. So let's call this one convert underscore temp. And this function is going to take a temperature. And then we're also going to want to say, what are we converting from? So from unit. And then we want to know what unit we're converting to, right? So we're going to pass in a number, which is our temperature. And then we're going to pass in an atom, and that will be like Celsius or Fahrenheit. And then whatever our 2 unit is, that'll be Celsius or Fahrenheit as well. And now we can tack on a nice little guard here. So when is number. So we want to make sure temperature is always a number. And then go ahead and do our do block here where we can write our code. We just learned about conditional statements. So we can do something like conditional or COND, cond. And then inside of the conditional block, we have our pattern matching that we want to evaluate specific code for if patterns match, right? So inside of a tuple here, we want to know if our from unit and our to unit matches a specific pattern. So if this pattern matches, let's say in this tuple, we want it to be from Celsius. So we'll do an atom Celsius. And then we want the to unit to be Fahrenheit. All right. So if this pattern matches, so if the from unit and to unit equals Celsius and Fahrenheit in that order, we would want to call our function. So I'm just going to return a string now so we don't get a warning, but this would call our Celsius to Fahrenheit function. Okay. And then we would want another unit or another pattern to match, and it'll be from unit to unit. And now we want the opposite here. We want this, so the from unit should be Fahrenheit, and then our to unit should be Celsius. And then if this pattern matches, we want to call our Fahrenheit to Celsius. And I just saw that typo function. Okay, so now we know how we're handling these two cases, and I have to spell Celsius correct here too. So we have 2 cases covered, but now we also need a default case. So we need something that will always be true, because what if someone passes in, two atoms that we don't recognize. We don't want it just to air out or get stuck in some, infinite loop if it was a recursive function or something like that. So our fall through statement is always just true. And then we can just return a tuple here with atom air. And then we can just return a string that says unsupported unit conversion. And now we have all of our cases covered here, which is pretty cool. Now we need to create two functions because we have two conditions that if are met, we need to call specific functions, right? So let's make a private function, so def p, because these functions are only going to be called from our convert temp function, okay? So we don't need access to it outside of this module. And this function is going to be called Celsius underscore to Fahrenheit. And it is going to take one argument, and we'll just put a C here. It's going to take Celsius. So it's going to take our temperature. Actually, we'll call it temp, so it's not confusing. And then let's do a do block here. And now we want to return our converted value. So to convert Celsius to Fahrenheit, you want to do temp times 9 divided by 5 plus 32. So that is the formula for converting Celsius to Fahrenheit. Now there is one thing you want to take into consideration is absolute zero. And absolute zero in Celsius is negative 273.15. So if it is negative 273.15 or lower, it's just below absolute zero. So it's not a viable number to calculate. So we would want to just return an error that the value is below absolute zero. So we want to handle all of our cases here. And to do that, we'll just do a simple if statement here. So if temp is less than negative 273.15, then we want to return our error tuple. So error, and then we're going to say below absolute zero. All right, so that's covered. Now, if it isn't below 273.15, then we want to do our calculation. So we can do our comma else, and then let's go ahead and just scoot this guy right next to our else block and hit save. So now we have our Celsius to Fahrenheit function, which is really cool. And now instead of this string here, we can just call our Celsius to Fahrenheit and pass in our temp variable. So we're almost done. We have one more function to write, and let's make another private one. And you've probably guessed it. This is going to be Fahrenheit to Celsius. And then it's going to take a temperature, and then it's going to have our do block. We're going to do this one a little different since this whole video is about conditionals. We're not going to use another if else block. We're going to use a case block. So here we can do case. In case, you need a condition check at the top here. And in our case, it's temperature. So we want to pass our temperature into this case block, and we actually don't care about the value, right? But we can use a guard here, which is really cool. So we can do when, and then if temperature is less than, this is our absolute zero in Fahrenheit, which is negative 459.67 degrees. If that is the case, then we want to return our error tuple, and that will be below absolute zero. Our next case, we don't care about the value again, but if this guard didn't trip, that means it's above negative 459, and now we can do our Fahrenheit to Celsius conversion, and that is inside of parentheses. It is temp minus 32 degrees And then we want to multiply it by 5 divided by 9. So it's just the opposite of our Celsius. All right. And we don't need, well, this is essentially our default clause. So if our guard doesn't get hit here, it converts. And now up here, instead of this string, let's go ahead and call our new Fahrenheit to Celsius function and pass in our temperature variable. Now, if we save this, we can go ahead and test this now. So let's go ahead and pull up our terminal. And we already have our shell running. And if you don't, just do IEX space dash capital S space mix. And then I need to recompile because we wrote some code since I started this. And now if we do temp converter dot convert temp, we can pass in our temperature. So let's say we have, I don't know, 30 degrees Celsius. So that means our from value is Celsius. And our to value, we want to convert it to Fahrenheit. All right, so we're passing in our temperature, the unit the unit of our temperature, and what we want to convert it to. And then when we hit enter, it returns 86.0 degrees Fahrenheit. So that's really cool. Now, if we say 86 degrees here, and then we switch our Celsius and Fahrenheit atoms around, we should get 30 degrees back. And there we go, 30 degrees Celsius. So that's really sweet, right? You're seeing how we can accomplish conditional checks in multiple different ways in one simple example. And now let's just check our air handling. So if we don't finish Celsius all the way, there we go, unsupported unit conversion. So that's really neat. And now we have one more we should check. So Fahrenheit needs to, if we're going Fahrenheit to Celsius, if we pass in a number that is lower than negative 459, so if we do negative 460, we should get our below absolute zero air. So that is pretty neat. We've worked through the essentials of control flow structures in Elixir, exploring if, else, unless, case, condition, and guard clauses. These structures are crucial for directing your program's logic and leveraging Elixir's pattern matching capabilities. Our exploration of these concepts in various examples, including our temperature converter, have shown their versatility and power in practical applications. As you continue to harness these tools, you'll find more efficient and expressive ways to handle different scenarios in all of your Elixir programs. And I'll see you in the next video.